Hi all. So in this video we are going to discuss about the problems regarding the mechanical translation system. So this is the figure given. The problem is write the differential equations governing the mechanical system shown in figure 1 and determine the transfer function. So we have to determine the transfer function of the body. Okay, and normally we know that the transfer function will be the output Laplace transform of output by Laplace transform of input. So normally the output we are taking it as a displacement x and the input we are taking it as the force F. Okay, so here we have to find the x of s, that is displacement x of s by f of s. Okay, so here by observing the figure there are two mass elements m1 and m2, which means two nodes are there. Okay, two nodes are there, and we have to draw the free body diagram first. Okay, from that free body diagram we will obtain the force balance equation, and by taking the Laplace transform we can arrive the transfer function of the model. Okay, so the transfer function is x of s by f of s. Okay, so normally in the questions in the university question paper, in the question itself they will ask to find the transfer function x of s by f of s, or they will ask to find x1 of s by f of s, like that. Okay, so here the question is only to determine the transfer function, so we are assuming that we are taking that the transfer function is, that is the output as x, and the transfer function is x of s by f of s. Okay, so first we have to draw the force free body diagram of the body m1. Okay, so for that we have to check whether what are the opposing force acting on the body m1 and what are the applied forces here. Okay, so from this point of view, by observing the figure, there is no applied force in this mass m1, and of course there are opposing forces. The opposing force due to the element k1, that is spring k1, and opposing force due to the friction element b1, and opposing force due to the mass of the body itself m1, and opposing force due to the b, and opposing force due to the k. And we know that the b and k is connected in between the two nodes. Okay, so we have to take while writing the equations, we have to consider both the displacement x1 and x here. Okay, so here first we are going to draw the free body diagram of the mass m1. And the mass m1, the displacement is x1 in this figure, and there are no applied force, and we are marking all the opposing forces as Fm. Of course the first one will be the opposing force due to its mass Fm, then Fk, then Fb1, then F this is Fk1, and this one is Fk, and this one is Fb. Okay, so utmost care is needed while you are writing the terms. Okay, this is k1 and this is k, do not interchange the values. Okay, so this is the free body diagram, and from this free body diagram we can write the force balance equation as always. The force balance equation will be, that is applied force will be equal to opposing force. Here applied force is 0, so we are adding all the opposing force, that is Fm1, Fp1, Fb, Fk1, Fk is equal to 0. And we know that we can find all the equations Fm1, Fp1, Fp, like that. Okay, so Fm1 will be m1 into d square x1 by dt square. M1 is the mass m1 and x1 is the displacement here. And Fb1 will be, Fb1 is acting only for the first mass, so Fb1 will be b1 into dx1 by dt, Fk1 will be k1 into x1. K1 is also connected for the mass m1 only. Okay, and but the other two elements, that is k, Fk and Fp, okay, two opposing forces, that is Fb and Fk, they are connected in between the two nodes. So the equation will be b into d by dt of x1 minus x, and Fk is equal to k into x1 minus x. So here we are considering the body m1, so of course we have to give the priority to the displacement of x1 here. Okay, so we are always writing the equations as x1 minus x, x1 minus x, like that. Okay, so here you can see the equations are x1 minus x. Okay, if you are considering the body 2, then the equation will be x minus x1. So at that time we have to consider the displacement of the body m2. So the displacement is x there, so equation will be x minus x1. So here we are considering the body m1, so the priority should be given to the displacement of m1, that is x1. Okay, and we are substituting all the equations here and we are taking the Laplace transform of all the equations. You know that the Laplace transform of the first time will be m1 into s square into x1 of us. Like that we are finding the Laplace transform, and just we are rearranging that, and from that we are finding the equation for x1 of us like this. Okay, and we are denoting it as equation 1. And next we are drawing the force free body diagram of the mass m2, and in that we know that for the mass m2 there are the applied force is f of t, and the opposing forces are fm1, fb1, fp and fk. So here f of t will be in this direction, then fm1, fb2, fp and fk. Okay, so fm2 will be m2 into d square x by dt square, fb2 will be b2 into dx by dt, and fb and fk is connected in between the two nodes fp and fk. Okay, so fp is equal to b into d by dt of x minus x1, fk is equal to k into x minus x1. So here we are considering the body 2, so we have to give the priority to the displacement x. So x is written first, and by writing the force balance equation, all the opposing force will be equal to applied force, and we are just substituting the values here and taking the Laplace transform. So in the Laplace transform we know that the x of s is taken common, and equation will be like this. So here for finding the transfunction we know that it is x of s by f of s, but in the last transfunction equation it should not contain any other variables. So here we know that x1 of s is there, so we have to give substitution for this x1 of s from the previous equation 1. x1 of s is written in terms of x of s here. Okay, so just substitute the value of x1 of s here, and the equation becomes like this, and by simply rearranging the values we will get it as, that is transfunction as x of s by f of s equal to like this. Okay, so this is the last equation. So after finding this, just try to write what they have asked in the question. Okay, they have asked to write the differential equations. So the differential equations, the two differential equations are there, we have to write it, and at last the transfunction. Okay, so I think all of you understand how we have done the problem. And one more question is there, write the equation of motion in S domain for the system shown in figure 1 and determine the transfunction of the system. So this is the figure. So by observing the figure we know that only one mass element is there. Okay, so which means only one node will be there, but here there will be another node also, that is we are considering the joining point of this spring and dashboard as another node. Okay, so two nodes will be there, one is the mass m and another will be the mass with the node here. So here we are considering that for this node the mass will be 0. Okay, the mass will be 0, and we are also assuming a displacement of x1 here. Okay, for writing the equations there should be a corresponding displacement for all the nodes. So here for the mass m the displacement is x of t, and we are assuming that for this node, okay, for this node the displacement will be x1. Okay, displacement will be x1. And first we are drawing the free body diagram of the mass m. While drawing the free body diagram of mass m, we know that applied force is f of t, and opposing forces are fm, then fb1, then fb2. Okay, so f of t is in the direction, and opposing forces are fm, fb1 and fb2. We know that equation for fm is m into d square x by dt square, because the displacement for this mass is x, and fb1 will be equal to b1 into dx by dt, and fb2 is connected in between the two nodes. b2 is connected in between the two nodes, so we have to consider both the displacement, that is x of t and x1 of t. Okay, so equation will be b2 into d by dt of x minus x1. So here we are considering the mass m, so we have to give the priority to the displacement x first. So we are writing x minus x1, and by writing the force balance equation, it is fm plus fb1 plus fb2 is equal to f of t, and just we are substituting the values here and taking the Laplace transform, we obtain an equation like this. Okay, and in that we have to find the transfunction as x of s by f of s, x of s by f of s, the same value. Okay, and by drawing the free body diagram of the second node, For here the second node will be this, and we are assuming that it has a mass of 0, and the opposing force will be fb2 and fk. Okay, so here m is equal to 0, and represent this x1, and opposing forces are fb2 and fk, and fb2 will be equal to b2 into d by dt of x1 minus x, and fk is equal to kx1, because the b2 is connected in between the two nodes, and we have to give the priority to the x1 first, so it is x1 minus x. Okay, and just substituting the values in the force balance equation. Force balance equation is fp2 plus fk is equal to 0, because no applied force is there, so it is 0, and just substituting the values here, and by taking the Laplace transform we will obtain it as x1 of s equal to b2s by b2s plus k into x of s. Okay, so we have to substitute this value of x1 of s in the previous equation. That is, in the previous equation the variables are x of s, x1 of s, and f of s. So we have to give substitution for this x1 of s for obtaining the transfunction x of s by f of s. So just write this value instead of this x1 of s here, and the equation becomes, instead of this x1 of s we are substituting the values. Okay, just b2s by b2s plus k, and by rearranging that we can find x of s by f of s as like this. Okay, so I hope all of you understand the problems well, and this is a sample problem, so just try to solve this problem. So thank you.